I have a lot of slides and I'm already a few minutes late, so I'm just going to get started. Let's make a show down. So I didn't know exactly what I wanted to do with this presentation. As an AI programmer, I could talk strictly about programming, I could talk about design. There's a lot of things in AI. So I just started by doing some free association about what AI is. There's the dictionary, my dictionary definition, the illusion of intelligence. There's what I think of when I say AI, which is characters in games, the behaviors that they do. I think AI is gameplay because games are interactive. The player is doing a big part of it, but if you have a gun, you need something to shoot. The AI is the second part of that. AI is acting. It's the characters. They have to be believable. A huge part of that is animations, but there's also, what the program is doing to drive their behaviors is going to, make them look like credible characters in the world or not. And I'm going to make the bold claim that AI is the linchpin of game development. Level design could make the same claim, whereas level design is kind of one discipline that unifies all the components in a game. AI is sort of a single feature or a single part of the game that almost every discipline works on. So if you've seen our AI reviews, we have programmers and systems designers, but we also have UI people, we have animators, we have sometimes have concept artists and modelers in there, we have level designers, audio effects, producers obviously. So very nearly the entire team works on AI. It's a big part of it. So I have a lot of words about what AI is. It's not super useful, so I started thinking about what if you subtract AI from games? What do you have left over? So what is a game? I read Howard at the top. For thousands of years, people had games without AI, and they looked like this, or like this, or like this. In these kind of games, there are rules, but the rules don't provide the challenge. Another player being present is what provides the challenge. The game is a fair framework for play, and the other player sitting across from you is what makes it a unique experience to play. But people had this idea, I think probably for hundreds of years, that it would be neat if you could play a game without that other person, just play against the game. And people did experiments like this. Does anyone know what this is? Have you seen this before?
Mechanical Turk.
Mechanical Turk. This is an 18th century invention that is ostensibly a chess-playing automaton. You would sit across from the robot, basically, and you'd take a turn, and he'd take a turn. It's a hoax. There was actually a man sitting in the box there, and I think the pieces were magnetized, so he was watching a mirror image the inside of what was happening. But yeah, there was this, this dream, at least, of playing a game without another person. So looking at AI and looking at games through that lens, I kind of came up with these definitions, which hopefully are a little bit more useful. AI is what makes video games unique. There isn't another medium out there that has the interactivity and the feedback loop that creates some reaction that the player responds to. There are pastimes and there are hobbies that are interactive, painting, making music, but having that system to that's going to change what the players do, and that's unique to video games. AI is a surrogate for other players because players used to be the challenge in games. AI, at least in single-player games, AI takes that place and presents the challenge. And AI is an abstraction of the developer. In a lot of ways, we are still the man in the box in the Turk. We don't individually challenge a person that goes and buys XCOM on the shelf, but we create a system that will provide that challenge to the players. So I want to take a look at what AI looks like in games. From the very first games, things like Pong. In this case, it's a very literal player surrogate. You could play Pong with another person, or you can play against the computer. There's not a character here. There's no embodiment of the AI in the game, but it's just providing that challenge. We move forward in time, we have things like the ghosts in Pac-Man. And here we are moving from that abstract player challenger surrogate to AI as a character, a very symbolic, abstract one, but a character that makes some decisions. And I really like the ghosts in Pac-Man. They have a very simple behavior. All they do is they travel straight down the hallways. They can never turn 180 degrees around. When they come to a junction point, they can either keep going straight or they can turn to the left or right if those paths are available. And just by changing, each of the ghosts has a different set of rules for when they'll choose to move straight or turn. And just by changing the rules, the developers were able to impart personalities on them, things like Dashful, because he's probably going to be hiding away, in a corner of the maze far away from Pac-Man because of the rules. Another, similarly low fidelity abstract AI from the times, Goombas from Super Mario Brothers. like the Pittman ghosts, they have some affordances. They have eyes, they have feet that animate. But if you think about what Goombas do in this game, they move left to right, they can fall off platforms. If they hit an obstacle, they turn around, they move right to left. They're not actually making any decisions. In fact, if you replace the sprite with like a rolling ball or something, we wouldn't think of them as a character or an AI at all. They look like a moving obstacle. And Super Mario Brothers actually has moving obstacles, the fire bars. What makes the Goomba different from the fire bar? Is it the affordances, the eyes, that we now think of this as a character? And what if we put googly eyes on the fire bar? So I don't really have an answer. I wasn't trying to prescribe an answer to this. I just thought it was interesting food for thought. So again, moving forward in time, we have things like Guys from Doom, which again, we're seeing an increase in visual fidelity here, and with that comes an increase in expectations because of the affordances of this guy. He has legs, so you expect him to walk around. Now, unlike Goombas or ghosts, he has arms, he carries a gun, you know that he's going to shoot at you. He has eyes and ears, so you expect him to see and hear you. He has mouth, so you expect him to vocalize. It looks like something that we might recognize from the real world, and we expect it to behave like something from the real world. And actually, in that regard, Doom kind of falls flat. It's a fun game, but these guys don't do a whole lot. When they see you, they attack, and then they continue to attack until one of you dies. That's all they do. So then we see things like Deus Ex, where, again, we've got another step up in visual fidelity, but we also have an increase in behavioral fidelity. These guys do have a more robust behavior system. They have a complex awareness state, so you can use stealth tactics to avoid them, and they show self-preservation. If they're close to dying, if you hit them with a tranquilizer dart, they'll run away, they'll try to hide. And what Deus Ex also does that I think is kind of remarkable, and I couldn't think of another game prior to Deus Ex that did this, is the way that they try to imbue the AI characters with a sense of worth. They want the player to respect them as characters. So spoilers if you haven't played Deus Ex yet, but these guys are the NSF agents. You're told at the start that they're terrorists. Around the end of the first act, you find out they're actually the good guys. Your brother in the gang has been working with them, and he invites you to come over, listen to their cause. And ultimately, what I think the developers hoped is that the player might feel guilty if he's been slaughtering them mercilessly. Like, you recognize at this point, these are people. They have stories, they have feelings. The developers want the characters in the game to have some human worth, and for the player to recognize the value of human life in them. And then, maybe there's also some cognitive dissonance then when you have to turn around and start fighting the guys that through the first third of the game have been your allies. And if we continue through those ideas, we get things like the Big Daddies and Little Sisters in Bioshock, which are very sympathetic AIs, and even ignoring the binary save and harvest choice with the Little Sister, people have very complex reactions to having to kill the Big Daddies, which are kind of these, by all intents and purposes, stalwart, honorable guardians of Rapture. It's a very subtle and kind of complex thing. I really like the idea of the players feeling something unique when they choose to attack these guys. And Bioshock also starts to tie these particular archetypes into the narrative more than we've seen in a lot of games. So there's other kinds of AIs which aren't specifically about characters. StarCraft has at least two kinds of AIs. You have the player surrogate. If you're not playing against another person, the AI is controlling the one or more enemy teams. And then even if you do have human players, there's AI that's running pathfinding and squad formation, making sure that the individual units are doing something smart. So Tetris, does anyone think that Tetris has AI?
I'm assuming what breaks you get is truly random and not actually there's no kind of game director AI that's like, oh, we could really use one of these bricks right now.
Too bad. If there is, that thing's a jerk.
Yep.
This is the number of times I've waited for the one piece.
Yeah. So I didn't actually do any research. I don't know how Tetris determines the next piece that you get, but it is some kind of behavioral logic that's determining, maybe it's weighted randomness, maybe it's, how long has it been since you got a long block? Maybe you've had 20 blocks since then, so it gives you another. Or it could be analyzing the playing field and saying, hey, here's what you really need, but I'm going to be a jerk and not give it to you. So, I would say Tetris maybe is AI in a very broad definition of what AI is. Triple Town, the same thing, with the next piece selection and where the bears choose to move. If you haven't played it, it's great, it's addictive. And Left 4 Dead is kind of the AI director concept. I don't know if it was the first game to do it, but it certainly popularized it, where instead of the designers prescribing, here's where you're going to fight a tank, here's where you're going to fight a witch, they put in opportunities for those things, but then the AI director is managing that as the players progress through the level and saying, all right, you just had a really intense fight, you lost a lot of health, you used up all your ammo, we're going to ramp down the intensity curve for a little bit, we're not going to spawn a tank, we're going to let you heal up and do those kinds of things. So that's not AI in the sense of characters, but it's definitely a system that's providing some challenge. So hopefully that's a good definition of what AI is. How do we make good AI? What is good AI? The kinds of things that people say, you might see in reviews or comments on the internet, things like AI is fun or realistic. I don't think realistic is a great way to think about AI. Realism is very tedious and dull in a lot of cases. What people mean when they say realistic is that they want to see reactions. If I shoot a guy and his buddy that's standing next to him doesn't turn and look and get freaked out, people are going to say that's unrealistic because it wasn't responsive. And obviously also if people say smart, they don't want an enemy that outsmarts them and kills them every time. But again, they want that, they want AIs not doing dumb things. When someone runs into a wall, and it's like, you could just walk through the doorway there instead of continuing to run into the wall, they're going to say it looks dumb. And smart is just not being dumb. I hope I got this quote right. It was actually from a talk that just happened at GDC. I saw it written up. Brian's a AI developer at Blizzard. And I think this kind of summarizes how I feel about AI. It's not about intelligence, it's just about giving the player a good experience. So, yeah.
Is Brian like super buff?
Yes.
Yeah, okay. That's Brian. He looks like Thor. Like he is ripped.
So I would say that good AI is just good design. And kind of a corollary to that, good AI has to fit within the game. My example of this would be when we were making prior to the Outsiders, the Altered in XCOM, we were struggling with exactly what we wanted them to do, and we were looking at lessons that we had learned from Bioshock 2. And at one point, we actually had feature parity so close between the Altered and the splicers from Bioshock 2 that we had them running side by side on 2 different screens, and it was like looking at the same character. They even had the, I think the pistol animation set from Bioshock on the Altered. And we were saying, all right, we have this exact same character. Why is it not fun to play in XCOM? And the reason was we weren't making Bioshock. We were making a different game. And we hadn't figured out quite what that game was. And so there was no way that AI, I think, was ever going to be good. Maybe a more useful role, I feel, is that good AI needs to keep its promise to the player. And that's kind of a hand-wavy way of saying that it plays fair. Obviously, we know AI sometimes cheats. We god them up, we make them not be able to see the player for certain encounters, whatever. But as long as the player doesn't recognize that, as long as they feel like things have been fair, that is good AI. So a quick step-by-step guide to being an AI programmer. 1, play Thief the Dark Project in 1999. If you saw Ryan Manson's lecture, maybe you recognize this screenshot. Thief was a very seminal project for me, not to work on, obviously, it's a bit more. It was when I played it, it was there weren't a lot of games at the time that had this fidelity of behavior that I saw in Thief. In a lot of games, like I was talking about in Doom, the guys see you, and they come and they attack you, and then they die. Thief created this more complex behavior system, where you'll have a guard on patrol, and then maybe he sees you, he hears you, you step out in the shadows for too long and whatever. He starts looking, and he's got VO that goes along with this. He telegraphs the transition between the states, and he'll continue to telegraph which state he's in by repeat marks. And he goes into the different pose where he's got the weapon up, and he's hunched over, and he's looking around. And like if you played Thief a lot, this walk cycle is probably indelibly burned into your mind because you just watch tensely from the shadows so much while they're doing this. And then if they see you again, you get like, they look like this, and you're probably screwed at this point. But you're actually not, because you can throw a flash bomb and get back to the shadows, and they can actually kind of rewind through these states. And that was something I hadn't seen before in games, and that was why Thief made a huge impression on me. I think I grew up knowing that I wanted to make games, so it was when I played Thief I knew I wanted to make AI. Step 2, it's been 5 years not learning about AI. I'm being a little bit sarcastic with this slide. For a while, songwriting replaced programming as a major passion. I wasn't actually slacking off the whole time. I was learning about computer science, data structures and algorithms, which I didn't really appreciate at the time, but it does actually inform what I do day to day. And if you want to be an AI programmer, you kind of have to know this stuff. So if I were to provide some actual informative stuff on how to get started with being an AI programmer, to make AI, you kind of have to have a game. I said good AI is good design. They go hand in hand. I would recommend if someone wants to learn how to make AI, that they start the same way that I'd recommend that anyone get started programming games, which is something like Python and the PyGame library, and actually learn to write your own games and write the AI for the context of it. There are some other ways, which is like Unreal Tournament 2004. Actually, I think the Australia guys run the 2K Bot Prize, which is like a Turing test for AI bots. It's convinced a panel of judges that they're playing against people in a death match. I did my master's project as an AI in Unreal Tournament 2K4, and there's UDK as well. I don't know if I haven't tried using it for projects. I don't know if it has enough game types and enough assets. Doing something in there, you do have the context of the game. It may not be the game, the perfect game to make your AI in, but it's a nice sandbox to play with. And likewise, Unity and UScript. I've only started to dabble in these, but for those of you who worked with Ken Hudson before, he's using this for some indie stuff that he's doing, and he sounds like he's really advocating for it. So, values that I think AI programmers need to have is like have a holistic view of AI. Obviously, I've spent like half an hour now talking about design and theory and not any programming stuff, and that's because for me, it's kind of, I can't decouple what an AI is and how it fits in the game from what I personally do as a programmer. Even low-level AI things like pathfinding are going to change depending on the needs of the game. So you have to understand where the AI fits into the game, what its role is. Be able to communicate with creators because, like I said before, there's a lot of people who work in AI. Almost everyone, every discipline in the team, they deal with an AI program at some point. And, everyone has their own unique jargon and you have to be able to communicate with people. And understand code performance because AI is arguably the most CPU-intensive part of gameplay programming. We have some very expensive functions like line checks against the world for vision traces, pathfinding, and we also work with large data sets like a path network. And understanding how memory is allocated and what the performance costs of those things are is hugely important. And I think AI programmers need to understand how to use a profiler and kind of think like an engine programmer sometimes. So, design and theory stuff aside, let's talk some finally about what AI programmers do. I'm going to focus on action game AI just because it's what I do here, it's what I know best, and if we talked about things like AI directors, we would never be out here this afternoon. I like to break things down to this sense, think, act paradigm. It kind of mirrors the way that we understand our own brains to work. We see and hear things, we think about that, process some information, and behave appropriately. And it also models like the flow of information, first receiving it and then thinking about it, and finally doing something in the game that's going to cause changes to the world, and then we sense those new changes and continue to loop. And then I'll talk about some related systems as well. So sensing is gathering information from the world. Things, I broke it down into periodic and event-based. It's not really a big deal. Vision traces, one of the most expensive parts of AI, but you have to know what the AI can see, what things are included. So we know the locations of entities in the world. We're going to trace lines to them and say, did we hit a wall that's blocking me from seeing that character, that kind of thing. Influence maps, I have an illustration for it because they're kind of hard to just describe. So if we imagine that we have like the blue team over there, the red team over there, and the red team is trying to chase the blue team, we're going to, you can imagine kind of like pouring a jug of influence over the map. It's going to spread out from there and show like over time what's the most likely places that the blue guy could have moved to. And then if the red character says, all right, from this position, I can see all this stuff. The blue guy isn't here anymore, but the hot spot is right there, so I'm going to try to move there. And he moves, and maybe he still doesn't see the guy, but now the remaining hot spot is in the little bucket in the center. He tries to follow that, and he finds the guy that's running away. That's how influence maps work. They're cool. We don't have them in XCOM, but it's something I felt like was worth mentioning. Event-based senses are things like when a character takes damage, or when the player's footsteps are usually a model of this. When you fire a weapon, it will emit some kind of, it's not a literal sound, it's not something that the player is hearing through his speakers, but it's an AI sound. It's something that the AI is aware of and can respond to. And you can use them for things that aren't actually sound. I think the Half-Life guys called them smells, but just if you want to have a character that periodically emits some kind of awareness event, you can hijack the sound system to do that kind of thing. I had to work this picture in here somewhere, and I didn't know where else to do it. Once we've gathered information from the world, then we have to do some kind of knowledge reasoning about it. This could be things like utility-based systems, which are mathematical models to maximize some kind of result. Things like we know about all the cover points in the world, use an equation to say which is the most valuable to me based on distance, based on relative distance from other enemies, lines of sight, things like that. Or expert systems, which are more like a list of rules that a designer will have written to say which is the best thing to choose from. And really, the think part of this, it's kind of the black box of AI. It's not always really well exposed through debug tools or to designers or things, but it's just about taking the big set of data that we've gathered from the sensing phase and producing some kind of discrete result. So we can say, we know about all the enemy characters, which one are we going to attack? We know, where do we want to stand? Where do we want to take cover? This might also be the best place to look for squad opportunities. Maybe one guy can advertise, I'm going to be attacking this guy, so I might provide suppressive fire if someone else in my squad wants to go and flank, that kind of thing. And then we write that to the blackboard, and AIs are able to act upon it, which is just running the most appropriate behavior. And this is the part that if any AI is exposed to designers, this is usually the part that they have control over. There's a lot of ways to model these. Finite state machines, which look like this would be the ghost when Pac-Man. Most of the time he's in the chase state. When Pac-Man needs a power pellet, he goes to flee. If he gets eaten, then he goes back and respawns, and either of those states can time out and go back to chase. And you can imagine as games get more complicated, like if each thing that an outsider could do were a separate bubble here, we would have sitting in cover, standing up to fire, throwing a grenade, moving along cover. Like each of those would be a discrete state, and having to manage all the transitions between those and store enough information about how to get back to the state that you were in after one of them completes, it gets pretty hairy. And so there are better ways to model them. One is hierarchical finite state machines, where we would encapsulate all those kinds of things into just a combat state and internally manage the transitions, so that if you say, this guy was in combat, now he's on patrol, but he has to go back to combat, the patrol behavior doesn't have to know which combat state to transition back to. Internally, that's all managed. Behavior trees, which are kind of similar, but they have this priority. You kind of read them left to right. So you would say combat is the highest priority thing you could be doing. Maybe the blue note is like a conditional saying, do we have someone that we can engage in combat with right now? If that fails, we're just going to move left to right, go to the next thing we can do, try to search for a target if we have one, that kind of thing. And these can be set up in like a visual editor. It would look kind of like the animation trees or whatever in Unreal. And I'll talk a bit more about it later, but this is actually what I want to do in future projects, is expose this kind of behavior system to designers so that instead of hard coding the behaviors, all this stuff can be changed very quickly. And then planning, which is really cool to an AI programmer. It's instead of structuring the large-scale behaviors, you say these are the atomic actions that an AI can do, things like movement, taking cover, firing a weapon, but you don't assemble those into any bigger structure. You just describe to the AI what's going to happen, what needs to be in the world for you to use that behavior and what's going to happen when you do it, and then you let the AI sequence those actions together on its own. Like I said, it's cool for an AI programmer. It's kind of like you just hand off a lot of the decision making, you delegate that to the AI. On the other hand, if you have an AI now that's doing some behavior and it's not really what you want, it's a lot harder to tune that and massage the behaviors that you want out of the system, because you did just kind of delegate that decision to the AI. So that covers kind of the sense, think, act paradigm. Some of the other things that AI programmers spend a lot of time doing is like pathfinding, which I mentioned before, learning about computer science during those 5 years when I wasn't learning about AI. Pathfinding is just a graph search algorithm, which is a common part of the computer science curriculum. The sort of things that people learn at first is like uninformed traversal, which would be things like depth first search. So if you have a graph, and you can imagine these are like path nodes in the world, depth first search is just saying, if you start from here, you're going to look at each node, you don't really care where you're trying to go. You're just going to look at everything in the graph. You're going to go as deep as you can, 1, 2, 3, 4, and then start backtracking. And go through the graph in that order. And likewise, you can do breadth first search, which looking at the same data set. This would say from the start, you look at all my immediate neighbors, and then you start looking through their neighbors, and you go through it that way. Which is great if you just want to look through an entire graph and see everything that you're connected to. But if you want to see, like, say you're trying to find a path from this node to this node, you're going to spend all this time looking at this stuff before you eventually get there. And this is just looking at a graph where there's no loops. But imagine if you had like an edge from 5 to 8. Your path that you would find would actually be, you come down here, you backtrack, and then you go to 8. And you'd say your path is 1, 2, 3, 5, 8, when actually you want that path. So these kinds of things are good places to start, but we really need to find the best path, which in computer science we learn Dijkstra's algorithm. So there's a lot of numbers. It's actually pretty conceptually easy. If we're starting from the blue node, we want to find a path to the red node. I'll just tell you right now the best path is to go this way, this way, this way, and we'll see how Dijkstra's algorithm gets us there. From the start, we add all their neighbors, and we give them a value, which is how far we've traveled to get there. So on this edge, we traveled 5 meters, we put 5 in there. Here we traveled 10, we put 10 in there. And then the next nodes that we look through are going to be the lowest value ones. So we look through all those 5s, and we expand through them. And now we add, for example, 5 plus 5, and we assign 10 here, and we assign 10 here. And now we have 3 nodes that have the value of 10. If we expand all of those, down here we've got 15, up there we've got 20, and through this one we get to our destination. So we found the best path using Dijkstra's algorithm, which is great, except we ended up looking at a lot of nodes we didn't need to, like these down here. Like if we're starting here and we're going here, why are we even going this way? Like that's the complete wrong direction to go. And in traditional computer science where we're concerned about results, maybe that's okay. In games, we're very concerned about performance, and we need to find the best path efficiently. So we can use a heuristic search to guide the path finding. And this could be something like, a naive best first search. So the numbers here are kind of like the straight line distance from the destination to each of these points. Like maybe that's 10 meters, that way is 8. And from the start, again, we look at our neighbors. We don't assign any values to them, they just have those values innately. We'll expand the node that's valued at 8, but it doesn't have any new neighbors. So then we go to the next lowest valued one, which would be this one over here that's valued at 10. Look at its neighbors. Now we have one that's 5. That's definitely the closest one. And now we have that path. Great. We didn't even spend any time looking down here. Any problems with it?
No, it's bad. It's not optimal.
It's not optimal. It's a different path than Dijkstra's gave us. Which maybe that's okay for games. Those actually talk this week at GDC. The players can't tell the difference between the best path and one that's 10 to 15% less efficient. But if we do want the best path, we can combine the benefits of Dijkstra's algorithm and best first search into what we call a star. So it's a lot of numbers here, but it's just what we've seen before combined into one graph. In the star, we add our nodes, but this time we add, for example, the cost to traverse this edge plus the value here, so 5 plus 8 is 13. Again, that's our best value node, it's the one up in the corner there, we can't go through it. But the next best one is here, so we're going to go through that. Now we have 2 nodes that are valued at 20. If we expand both of those, we get to our destination that way. Just like Dijkstra's, we get the shortest path, but we didn't spend any time looking down here. AI programmers also spend a lot of time working with animation. I won't talk about just behavioral animation, because that's really just up to the animators to do something cool, and then we just say, play this animation now. But the kinds of things where programming actually has to select animations is things like locomotion. After we plan the path, we have to have the guy move along it. We're not just going to have him play a uninterpolated block cycle through the whole thing, so foot skate and he won't turn properly. So there's a lot of ways we can do this. I chose this image from AIGameDev.com where we planned a path that goes on like this, and then they're actually using an A-star search instead of through physical space, through the selection of motion clips that are available. And just illustrate that by like what we see, hopefully you can see this little curve down here. Like we might have a motion clip that turns us a little bit to the right. And we say, well, that's going to diverge too much from this path, let's try something else. And so we build up this chain of motion clips through an A-star search. This way, that ultimately leads us to the destination. And so now we're generating both a path and the sequence of animations that are going to move us there.
Would that result in the coolest possible set of moves that land you at that point?
Ideally, yes. There's a lot. So Bioshock actually used a system like this. We don't run XCOM. It's some hairy code. Like we all tried to avoid that code as much as possible, but it can produce some really cool results. And what it lets animators do is just like you can throw in, a twist animation and just say like, here's an animation where the guy slings his weapon over his shoulder while he's walking, and it could just, maybe it's a different length or something. It will just throw those in where possible.
I can definitely see a more acrobatic character making great use of this.
Yeah, absolutely. Other things that we do with animation are special navigation, vault overs, jump downs, things like that. Aiming and looking, which is just kind of specifications of the general point some set of the skeleton's bones in some direction. And smart objects, which were kind of popularized by The Sims, but I think they have a lot of utility for action games as well, which is kind of like encapsulating behavioral animations in the object where it's going to be used. So like this guy that's sitting here, he doesn't usually need to know how to play chess, but when he sits down at a chess table, that object is actually going to tell him, here's what you do while you're here. And it's not strictly an animation problem. Like this would also have some script that runs when the guy sits down and some metadata to advertise, here's why you would want to play chess right now. But yeah, they're pretty cool. I think we can use them in action games. For example, something like the health stations in Bioshock could be a smart object. It could advertise, when you're low on health, run over here, play the animation, and you'll get healed up. So we've mostly been talking about systemic AI things, but sometimes we need to override systemic AI to do special sequences, cinematic stuff, or just like an introduction to a character where he has to behave a little differently than he might normally. So the ways that we can do that are give a level designer full control over the character. They basically just puppeteer it and control those atomic actions, like move to, fire your weapon themselves. The problem with that is that it's a lot of work if they're trying to replicate a behavior that the AI normally does systemically. So what we can do instead is we actually say, here, use the systemic behaviors, but control which targets you're using. So if you want to have a guy that, in this scene, he's always going to attack this particular character, we can say, don't do your normal target selection, just always attack this guy, and maybe always take cover here. And so that's much better bang for the buck. On the other hand, it's a little bit fragile. You can end up with the behavior changing because the AI team didn't know how it was being used in this level, and now the level is broken because the AI's systemic behavior doesn't work with what they intended. But yeah, usually between these two things we have a lot of options. And then another thing that we can't do on Bioshock or XCOM, but that a more data-driven system might allow, is things like actually letting the scripters augment behaviors. If you can have a designer set up some kind of new behavior for the AI, you can use that just on a particular archetype for the intro character. I talked about like behavior trees with the implicit priority. You could just put at the far left of the tree, here's a scripted behavior. After it runs once, we're actually just going to remove that from the tree. But so when the guy first comes into the scene, that's all that he wants to do, and that can just be authored for that particular character in that one case. So to wrap up, where we've been with Bioshock 2, we had 3-ish AI programmers. We also had Linus in Australia for a little bit. And again, 1-ish AI designer. We had hard-coded behaviors that the designers could configure. They could tune the parameters on them, but the actual structure of the behaviors was written by programmers. We had kind of sympathetic AIs like the Big Sister, or the Big Sister too, but the Big Eggs and the Little Sisters. On XCOM, the team has grown. The ratio is starting to shift toward designers, although at one point we did have, I think, 7 AI programmers. We still have hard-coded, configurable behaviors. We have friendly AI as a first-class feature, which is a huge thing that we didn't have in Bioshock 2, and that's the agents, of course. On the other hand, we've kind of lost the sympathetic AIs that we had on Bioshock. Most of the enemies are kind of cannon fodder, which is fine. We put a lot more work into the agents instead. Where we're going, and I should say this is where I want to go with future development, more expressive AI design tools. We really need to try to cut out that like 24-hour turnaround when a designer wants to change something and the programmer goes and does it, and then it goes through QA and eventually a release gets made, and then maybe a day later, the designer is able to see the results of this change. Like that's a very slow process. And some of this we've tried to roll out to XCOM, configurable sense and think modules, things like giving designers more control over target selection. There's still more that we can do. Right now we have hard-coded rules for target selection, and designers can tune those numbers. But we could actually say all those rules are set up in Kismet or something. And then using a data-driven AX system, whether it's behavior trees or hierarchical state machines, whatever it is. But again, expose network kind of Kismet-like interface to where designers can at least prototype that kind of stuff. A lot of people that will use those kind of systems, they will have designers do a first pass, and then engineers may later come in and collapse a huge set of behaviors down into one atomic thing that can run more efficiently. But yeah, it's a great place to get started for rapidly developing some AIs. If we can cut AI programmers out of the behavioral loop, we can work on things like influence maps and smart objects that I talked about, which I think it's hard right now to justify some of those things, but if we have the time to do them and we can see the results that they bring to the game, they would be very valuable. But like right now, we've talked about influence maps on XCOM, but it's hard to say like how would knowing where the player might be tangibly within that, especially when we're looking at we could spend time there or we could spend time making the drone better or making the happen better. And hopefully, and this is just kind of my one pretentious artsy thing, but I'd like to see more progressive AI design, less of cannon fodder enemies and more like the direction that Deus Ex and Bioshock were going. Strong unification with narrative, and again, respecting the AI characters as some kind of person and being able to see the value of life in them. That's it. Any questions?
What's your favorite AI?
My favorite AI is probably the Guardsman Thief. Yeah, it was just so influential to me. They're not the best AI out there anymore by any means, but there was clarity in what they were doing at all times, and it's still a good touchstone for AI development.
What did you think of Black and White with the creatures they trained and all the activities that they do?
Yeah, I didn't actually play Black and White. I had a slide in here before I cut it out to try to make this fit into 50 minutes, which was about things that we don't do as much in AI that kind of come from academia. One of those is learning, whether through neural networks or genetic algorithms. People have tried to do that with games, and Black and White is an example where it probably worked better than other games. But still, it's hard to tune, and it's hard to develop those kind of games when so much of the player's experience may be left up to whatever the AI does in their particular case. Yeah. Martin first.
Do you know much about like AI being used for narrative purposes, like drama management and that kind of thing?
I know that it has been. I think Facade is the example that people always drag out. I don't know a lot about how that's done.
Okay.
Yeah. Like I said, action game AI has kind of been my forte.
The director in Left 4 Dead kind of goes along those lines a little bit, though, right?
Yeah, absolutely.
I mean, yeah, actually, both Facade and Left 4 Dead operate under the principle that there's like an interest curve that they're trying to maintain. So like, whereas Left 4 Dead is more oriented towards like balance and not getting your ass handed to you. Facades is more about like the intensity of the situation and that influences like the way characters deliver lines and stuff like that.
Cool. Matt, you had a question?
I was wondering about your perspective on player toolset versus AI toolset and supporting them to as much of an equal point as possible, or cutting back on AI difficulty and removing toolsets there to like supplement the rest of it and make it better, and how you kind of balance all of that and make the decisions. Is it mostly on the design side? How much comes into the tech realm in terms of limitations?
Yeah, I think that would usually be something that the designers would make the call on. I mean, my personal feeling is, as much as you can have parity between the player verbs and the AI verbs, do it. Players don't want to see the AI doing cool stuff that they can't do. And likewise, if the player can do something cool and then he sees an AI doing that, or even if you could train player verbs through seeing the AIs do it, like that's going to be a win for the game. But Yeah, it doesn't really impact programmers except when there's something that, you know, maybe has been developed, often player land. You know, if Will is working on something and then it's like, can we make the AIs do this too? Well, we didn't develop it with that in mind. Maybe it's going to be a lot more work. Yeah.
So, some of the people the retrospective heard of Deus Ex, that some people particularly liked it because the AI seemed almost stupid. It let them get away with things that they probably couldn't have, sneaking in certain places or pulling things off. How do you know if you've made the AI too smart for the player? Is it just too vicious, or?
That's interesting because actually my experience in Deus Ex is that they almost tuned it too difficult. I have a lot harder time playing stealthily in that game than I do in Thief. But yeah, again, I think it comes down to design tuning and, you know, when you do focus testing, do people feel empowered? Is it a game where you're supposed to feel empowered against the AIs? Or is it supposed to be something where you're very tense? And either way, are you achieving that goal? But yeah, Deus Ex in particular, they tried to do so much. You know, I don't feel that the quality of their AI was as good as it could have been. I still like it for everything that they tried to do, but they did, yeah, like the stealth isn't up to the quality of something like Thief or Metal Gear Solid. The shooting isn't as good as Quake 2 or whatever else is out at the time.
Yeah, it could just be the, you know, nostalgia glasses that people put on.
Yeah.
People like in GoldenEye, you can shoot a hat off of the enemy and he doesn't notice. Like,
Yeah.
it's stupid, but it's kind of funny and
Yeah,
entertaining.
absolutely. Yeah.
If we're not doing influence maps, how do we track last known locations present?
So what we do on XCOM is we just know the last known location, but we don't infer any other information about that. You can pursue to that point, and if you can't see them from there, the AIs will throw their hands up. On Bioshock, they did something where we stored the last known location, but also the velocity the character was traveling at that time, and extrapolated, just saying, assume that they continued traveling in that direction forever, they might be somewhere over there. Obviously, if you have really maze-like environments, that's not a great place to start, but yeah, I guess it worked. No one complained about it in that game.
Well, it's probably a good time to stop because there's a bunch of people coming in at 2 who need to set up their room. So any other questions? Otherwise, we probably should get out of here and make it easier for them. Nice work, Dave.